career counseling firm which focuses on helping students achieve career clarity. We have helped over 120,000 plus students and partnered with more than 150 reputed schools across India to achieve the same. We have the world's most advanced career planning platform for schools, developed by a team of alumni from Harvard, ISB, IIT, IIM, and world's leading psychometricians, and incubated by IIM Ahmedabad and ISB Hyderabad. We've also been awarded the Best Career Guidance Platform by National Startup Awards, Entrepreneur India, and Education World. We have also been awarded and recognized by the Ministry of Science and Technology India and Ministry of State UAE. Without further ado, I now introduced our speakers for the day. We have Dr. Sunita VM. She's the head of research and training here at Mindler. Dr. Sunita VM started a career as an educator in physics and electronics, guiding students through their academic, research, and professional pursuits for more than 2 decades. Her contributions to academia include publishing 9 influential papers in reputed scientific journals and advancing knowledge in her field. While she found joy in teaching and research, she also recognized that many students face challenges in identifying their career paths aligned with their interests and strengths, particularly in the rapidly evolving STEM landscape. As a passionate mentor and educator by profession, with over 26 years of experience in teaching, mentoring, and training, the knowledge and experience have always allowed her to gain a greater understanding of the needs of the next generation, apprehend their struggles, and support them to carve out a decision regarding their careers on their own. Motivated by this insight, she transitioned into career counseling to leverage her experience in academia and her understanding of scientific disciplines to help students and professionals explore and succeed in emerging career opportunities. Our second speaker for the day is Ms. Anandita Layak. She is a senior career coach with Mindler here. Anandita is an internationally certified career coach with a deep passion for empowering students on their educational journeys. Currently working with Mindler, she combines her expertise in career coaching with over 12 years of rich experience in the automobile industry, having contributed to leading OEMs like Maruti Suzuki India Limited and Honda Motorcycles. As a mechanical engineer herself, she has excelled in diverse roles spanning manufacturing, design, and development. She now leverages her industrial insights to help students make informed and impactful career choices. Beyond her professional pursuits, she is a dedicated Kathak performer and teacher, sharing her love for this classical art form with children, embodying her commitment to both education and empowerment. I now hand over the webinar to Dr. Sunita and Ms. Anandita. Thank you so much for joining in.
Thank you, Urvi. Thank you.
Thank
Thanks
you.
a lot.
A very warm welcome to all students, parents, and educators. Thank you for joining us today. As we step into December, the final month of the year, is the perfect time to gear up for your preparations. I'm sure you all are now more focused and confident as you get ready for your upcoming, say, pre-board exams, board exams, entrances, and even application deadlines. A quick question to the audience. How many of you have decided on their, program for undergraduation? What kind of programs are you planning to pursue at undergraduation? Please use the chat box. Give us your replies. We would like to understand our audience. I'm sure you must have looked into, what are the different colleges, what are the different programs. There should be certain kind of plan A, plan B, plan C. Okay. We are getting some replies. Economics, medicine, computer science. I'm sure you are getting little difficulty, little, scared about which program to go for. What will be the right choice for me? Chemical engineering, great. There are so many branches. in technology, in STEM domain, computer science, a lot of students are looking at engineering. Great. Yes, entrances, yes. J, other state entrances. Pharmaceuticals. Wow, wonderful. It shows a lot of you have already a plan in place, and your preparations, I am sure they are going in the right direction. And many of you are looking at, engineering programs, tech programs, STEM programs. Today, the domain of STEM is more dynamic than ever. It is evolving rapidly in response to global challenges and opportunities. Today, a lot of emerging fields are now taking the center stage. And even the skill set that is required to be successful in these fields have expanded. The emphasis is not only on your academics excellence, but also on your adaptability, interdisciplinary knowledge, and practical approach to problem solving. To meet these demands of this dynamic landscape, educational institutes are also focusing on introducing innovative and interdisciplinary courses. These courses will equip students with future-ready mindsets. Now, these programs are also a blend of technology, and they include creativity, critical thinking, real-world application. They prepare graduates to thrive in careers that did not exist a decade ago. Now, today's webinar is designed to offer valuable insights to students, parents, and educators about some emerging programs in engineering and technology. So without any more delay, let's just begin. Very good evening to Sunita ma'am once again. Welcome again.
Thank you.
I'm going to put up a lot of questions to you, and I hope this session brings a great deal of awareness to all our audience.
Sure.
My first question here is the computer science technologies, artificial intelligence, programming, data science. These are all getting integrated into mathematics and physics, a very interesting concept. How do you see the significance of these programs?
Yeah, first of all, a very warm welcome to all parents, students, and educators from different parts of our country. And definitely this webinar will provide you some valuable insights into what these programs entail, their relevance in today's market, and how they are going to power for an exciting and impactful career. So for parents also, we aim to give you a brief understanding about these fields so you can make some informed decision when guiding your child through their education journey. Now, we all know the market in India is growing towards research, development, and in several sectors like aviation and space, finance and market, banking, healthcare and bioscience, network security, and lots of higher-end technologies. So to address these challenges in these fields, the younger generation require a strong mathematic acumen with a computing perspective. Now, if you see, we have listed some 4 programs over there in the slide, and all these programs are some of the new programs that is emerging out from different universities and institutes. Now, this Maths and Computing is a program that is going to fill the skill gap in the students. It is a multidisciplinary course which is designed for students who wish to work in research development and do some innovation with futuristic disciplines and next generation technologies that includes or that require intensive knowledge in mathematics. It also includes theoretical computer science, statistical analysis, and little bit of financial principles also. And in some institutes, they also include humanities, which is actually a must for STEM professionals involved in innovation and research nowadays. Because when it comes to humanities, These graduates, as you know, they are involved in creating systems and tools to be used by large number of people who are not technologists. As a result, such systems should be designed with a larger humanity in mind. So the students need to be aware of how humans as individuals and as a members of a society may use them so that they can include that kind of thought process while making some innovations. So that is the idea of adding this humanities to these STEM courses. Now, when it comes to the scope of this particular degree, math and computing, the scope of degree spans to multiple high demand domains, I would say, just not just domain, like cryptography, financial mathematics, finance modeling, software development, parallel computing, artificial intelligence, machine learning, and even quantum computing. All these areas have the potential to offer a broad range of career opportunities for students. Now, when it comes to if you see finance, banking, and investment industry, they need professionals well versed with mathematical methods, computer statistics, and economics to work as financial mathematicians or financial analysts, investment bankers, quantitative financiers, finance modelers, just to analyze the financial market. So this particular course can be a good course for those students who wants to get into that financial sector from PCM background. Very good area. Then for those students who want to get into tech background, they can under the category of data analysis or data science and algorithm design and dealing with AI and machine learning, developing intelligent systems and algorithms. For those students who wants to get into these areas, again, this particular course is a very good course. They can take it. And operational researchers, anybody who wants to get into maths as a main domain, where they use mathematical models to solve complex problems, optimization, and decision making, those students also can look this maths and computing as a wonderful program. And for engineering students who are very much interested to become simulation engineers, control systems, getting into engineering analysis, optimizing, which includes healthcare systems, that is biology plus mathematics, being a system biologist or a computational biologist, those people also can look this particular degree or this particular course as a wonderful course. When it comes to the career areas, you can find yourself in game theory as a game theory specialist, stock market analyst, risk analyst, market researcher, system analyst, or even computer scientist. One thing what we have to remember is you cannot replace this particular course instead of mathematics or computer science, because the outcome of this particular course goes beyond what is expected from learning maths and computer science. So when it comes to this particular course, you learn about AI and its subset technologies much faster than getting into computer science. Okay. Now, when it comes to coming to the curriculum, when it comes to the curriculum of maths and computing, the curriculum is completely different in different institutes. Means when somebody is going to take up this course, mathematics, BTech in mathematics and computing, I want to get into this course, they will have to go through the curriculum that is offered by different institutes and then get into the course, get admission to the course, because each institute will have different curriculum. For example, IISc is giving BTech in mathematics and basic computing. In their syllabus, they include electronics and electrical engineering. They also help you to understand what is AI, what is machine learning. They also have added humanities courses into their curriculum. They also have added software courses, soft core courses like physics, chemistry, biology, and material science also. So this is the curriculum that is provided by IISc, which makes up that student round enough to get into any industry that they want after their 4 years of graduation. And when it comes to IIT Kanpur, they see here it is a merging of two subjects. One is maths, another one is computing. So when it comes to IIT Kanpur, they give more importance to mathematics and less importance to computing. And when it comes to IIT BHU, they give more importance to maths and equal importance to maths and computing. So each college, the curriculum will be different, giving more importance to maths or less importance to maths, or more importance to computer science or less importance to computer science. So it is very much important for you to understand about the curriculum and then take up this particular course. Regarding the job opportunities, there are enough industries that is waiting for these graduates, I would say. Because when it comes to technology center, Google, Microsoft, Amazon like companies, they look for algorithm designers, computer scientists. When it comes to finance and banking, they look for quantitative analyst or a financial modeler. When it comes to companies like ZS Associates or MU Sigma, these people are looking for, they are very good in data science and analytics. So they look for machine learning engineer or a business analyst. When it comes to some e-commerce online platforms like Amazon, Flipkart and all, they need operational analyst or a data engineer or a supply chain modeler. So all these companies will recruit graduates from the background of maths and computing. So how will I be placed? I can be called as data scientist or an analyst. I can be called as quantitative analyst, or I can be called as machine learning engineer or a cryptographer or a financial engineer, more like that. And the roles depends upon, or the name of the designation depends upon each company. It differs from company to company also. So this is regarding BTech in math and computing. When it comes to the next course, if you can see CS and financial technology, this is an amazing course again, and it is an interdisciplinary course where it combines the computer science with the applications of technology in financial services. You must have come across many payment platforms like Paytm, PhonePe, Google Pay, and all, right? So it makes the transactions very easy and comfortable for us. But at the back end, there are many careers that is working, and one among that career is this fintech. Okay, one among that designation that works behind is fintech. So these people, apart from the knowledge of computer science, they also learn they also get little bit exposure to the financial transactions also. So you will be learning blockchain, artificial intelligence, data analytics, application programming interfaces that is related to financial products and services. The main functional domain here is banking, payments, capital markets. So there are a lot of opportunities for those students who are taking up this course in fintech companies. Fintech companies in the sense, as I was telling you, Paytm, Razorpay, Stripe, Square, Coinbase, they need blockchain developers. They need digital payment specialists and software engineers. And again, banking and financial institutions. JP Morgan Chase, you must have heard about that company, HSBC, ICI Bank, HDFC Bank, all these people look for financial software developer. So they also look for risk analyst, right? And investment firms like and hedge funds like Goldman Sachs, BlackRock, all these people look for quantitative analyst and a financial engineer, data scientist, insurance technology, like companies like Lemonade or Policy Bazaar. They need actuarial data scientist or platform engineers. So like that, there are a lot many opportunities for these students who is combining CES with financial technologies. In these companies and all, you will be called as, again, blockchain developer or a financial analyst or a cybersecurity specialist or even AI ML specialist or quantitative analyst. These are some of the roles that you will be adhering with these companies, having this course in your kitty. Now, coming to computational engineering, this is another wonderful course, I would say. This is something where you will be using computers to solve real-world engineering problems through simulation and data analysis. Instead of building or testing physical models, engineers use maths and computer algorithms to predict how things will behave. I can give you an example here. Definitely, then only you will be understanding that. You are designing a new airplane wing. Okay, imagine you are designing a new airplane wing. Instead of building multiple physical prototypes, when you are building an airplane wing, you have to build a lot of prototypes. Each time you will have to test it to know how it functions, right? And Anindita will be knowing better because she was from automotive industry. In automotive industry also, you will use the same thing. But when you're building each prototype, the time consumption is more, and the cost of building a prototype for materials, manpower, everything, the cost is also more. So when it comes to computational engineering, it allows you to create a virtual model in a computer, and using simulation, you can test and test how the wing will perform under different weather conditions, speed and pressure of the wind, right? All without stepping out of the lab, into the lab, not out of the lab, into the lab. So here, apart from that physical thing, generally traditional engineers, what they do, they focus on physical experiments and build models. Now, this computational engineering people, apart from understanding how to make the physical experiments, they know the programming skills, they know mathematics, they use advanced software skills to simulate this and understand all these things. And this makes essential for those who are in automotive sector, who wants to get into aerospace sector, or even healthcare sector also. So major employers in this industry for this particular course is aerospace. As I told you, aerospace companies, automotive companies. When it comes to automotive company and all, no, they want to know the crash simulation analysis when the automobiles. Am I right, Anandita? Yes.
Absolutely, absolutely.
When
There are a lot of
automobiles crash.
simulations that are done.
Yeah.
Yes.
So they need to know that, right? So crash simulation analyst or computational fluid dynamics specialist. Then in manufacturing and in industrial automation, they need to know the simulation engineer, additive manufacturing expert. For all these purpose, this particular course will give you enough career opportunities. Even in healthcare and biomedical engineering also, they need computational bioengineers. And even in the software development also, simulation software developer or algorithm engineer, like that, there are too many posts that comes in. So you will be called a systems engineer sometimes. In sometimes you will be called a simulation or modeling specialist, or you will be called as high performance computing specialist, which is the emerging thing right now. Okay, so with computational engineering, these are, or more is there, but these are some of the things which I have handpicked from the careers. More careers are available for those students also. And coming to the last course in the slide is engineering and computational mechanics. It is about combining physics laws of mechanics with computational tools to solve problems that would be too complex to understand by hand. So graduates will be equipped with the skills of physics-based modeling, numerical methods, and computational tools, which are applicable across variety of industries. Here also, I can give you a wonderful example for you to understand this. You, all of you must have enjoyed a roller coaster, right? I am actually very much afraid of that, but I know the kids very much enjoyed that. And the one of the biggest thing here is they should make sure that it's not only thrilling, but it is also safe for the people who are in the playing that. So to understand how strong the tracks need to be to support the weight of the car and the passengers, how fast the cars is moving in different points, okay? How much stress the turns and the loops will put in on a structure. All this has to be calculated meticulously so that it is allowed for playing, right? In that case, this computational and engineering mechanics, engineering and computational mechanics will be very useful, because instead of manually calculating it, computational mechanics allow you to model and test everything on the computer. So then only you can go and do the model out of it. So that is what this course is all about. And when it comes to this, again, aerospace, defense, automotive, energy sectors, civil and structural engineering, biomedical engineering, robotics and manufacturing sector, all these sectors will open career opportunities for new people, those who are taking this particular course. You will be called again a structural analyst or a fluid mechanical specialist or computational designer or a data and algorithm developer. So like this, there are many career opportunities available in this. Now, for all these courses that is put up in the slide, you need to be good with mathematics. I should love mathematics. And if I am somebody who love finance, then the first two courses, mathematics and computing and financial technology, works very well. And if I am loving simulations, or if I am into physics and mathematics, the last two, computational engineering as well as engineering and computational mechanics, works well for you. For any areas which looks into solving complex problems, you can get into maths and computing. So I think you would have got some information about all these four careers, and these are emerging careers for sure for now.
Absolutely. And with those examples, I think the students of grade 12 with a science background would be able to relate very well where they are going to apply this kind of a program. Moving on, the next question that I have for you, ma'am, is similar. Computer science technologies are also blending with some core engineering programs. What do you think the students should know about these kind of programs?
Anindita, can you move on to the next slide? See, if you can see, there are some four courses that we have listed in this slide. And here, you can see computer science with communication engineering, systems engineering, electrical engineering, and electronic engineering. This kind of course is available in the market right now. It is nothing but integration of computer science with the core engineering part. Why core engineering? Here also I can explain you. See, when it comes to computer communication engineering, it focuses on designing and development and maintenance of systems that enable communication between people and the device. When it comes to the example, you can say mobile, internet, satellite systems, and even wireless communication also, communication devices also can be an example. And when it comes to mobile, when you make a call, you send a text from your smartphone, you're using the communication engineering technologies at the back end. So your sound is converted into electrical signal and it reaches the cell towers and it is processed there by the network systems, and then only it reaches the other person. But at the back end, the communication engineers would have designed the technology and infrastructure that supports this mobile communication. So this includes cell towers, signal processing, network management. Everything happens at the back end so that it allows the communication very smoothly. So to make these systems efficient, secure, and highly performing, the communication engineers need to have a strong understanding in computer science. Now, this knowledge helps them in data processing, network management, software development, cyber security, and integration of new technologies like Internet of Things. All this, it will help them. So the major employment sectors will be telecommunication companies like Sony Ericsson, Nokia, and network and internet service providers, Cisco, Juniper Networks, and defense and aerospace, and even space companies like where they do research like DRDO, ISRO, Boeing, cybersecurity firms. All these are major employment sectors for this particular course. And you will be called as network architect or a communication systems engineer, wireless technologist. Like that, there are many roles available depending upon the company. Now, when it comes to systems engineering, this is going to be an emerging sector for long. Most of the time, what has happened is all these days, the systems engineering was considered as only a master course. But now it is being integrated with computer science to give because nowadays the need for system engineers has increased. The demand for system engineers are there, and it is going to exist for another the rest of the years. At least for 10 to 15 years, it is going to exist because it is the art of making sure that all the parts of a complex project work well together. So it is about looking at a big picture and ensuring everything fits and functions together efficiently. For example, I am taking a smartphone. A smartphone is a combination of both hardware and software, right? When it comes to hardware, the screen, battery, and the processor becomes the hardware. When it comes to software, it is the apps and the operating system is the software, okay? And this software is designed by computer scientists. So without the software and the hardware working together, the smartphone will not function, right? So here, both these are going to be important. Computer science is about developing the software and algorithms, and system engineering ensures that the pieces of these system work synchronizingly with the software. So that is the work. Now, where the system engineers find their job opportunity is they find it in technology. System engineers help in developing software and hardware systems that integrate seamlessly, whether it is a smartphone or smart home system or any large network. They have to look into that. In healthcare also, when it comes to improving some medical devices like patient monitoring system or even the logistics of health delivery system, there also they will have enough work. In manufacturing, they make sure that all machineries, human resources, logistics involved in a factory work together efficiently to produce a goods. So this is the work of a system engineer. Very simply, if I have to put, it is making sure that all the parts of a complex system work together. So whether it is a car or a smartphone or an aeroplane or a hospital, system engineers ensure that different components, systems, and people involved in that work smoothly. So this is the work of a system engineer. So they should be very good in problem solving, and they should know how different systems interact, and they need to manage large projects also. So the major employment sector comes from automation and control industries where there are lots of hardwares, and major people who are in this industry are Siemens, ABB, like companies, they are in this industry. IT services, where TCS, Infosys, software product development companies, research labs, and think tanks. All these are some of the employment sectors for these particular course, the students who are completing this course. And you will be called a system architect or a software system developer or an automation engineer or a data systems analyst. So this is about systems engineering. Now, coming to the next, electrical, computer science and electrical, and computer science and electronics, both overlap each other at many places. Now, when it comes to electrical, we all know it is about designing, developing, and managing electrical systems, which includes circuits, power systems, and a little bit about electronics also, right? So the best example here for computer science and electrical engineering is the robots, where electrical engineers, they create circuits and sensors, actuators, right? And the computer scientists, what they do, they program the robot software to respond to those sensors and perform the task like walking and picking up the objects, all those things, right? And even the electric cars also, you can see. The electrical engineers work on car batteries and electrical systems, and computer scientists, they develop a software that control the car self-driving or navigation features. So the collaboration of hardware and software is going to be important. So here, devices like laptops or drones, medical equipments. Here you have an hardware and a software also should be there to work it seamlessly, right? So that is nothing but computer science plus electrical engineers. So it means you should have a strong domain knowledge and a knowledge in computer science to work in these industries. This collaboration is really very good. And the employment sectors are those who are manufacturing semiconductor and chip design companies, consumer electronic manufacturers like Samsung, power and energy management firms robotics and AI companies. All these are the major employment sectors for this. And the roles you will be handling, being a embedded system engineer or VLSI design engineer or a robotics engineer or a software hardware integration specialist. So these kind of courses are available now in the market again. Now, when it comes to electronics engineering, we know that when it comes to electronic engineering, it is about designing and developing electronic devices and systems. It involves circuits, sensors, and electronic components that actually power the devices like what you say, smartphones, TVs, and medical devices, right? So the very good example is creating microchips, designing the circuits in a phone, or working on devices like smart watches or drones. These are the major areas where electronics engineering comes into existence. Now, when it comes to this electronic engineering, if you consider smartphones, these electronic engineers designs microprocessors, sensors and circuits inside the phone. So the computer science people, they develop apps and operating systems like iOS and Android. So the combination of these two, the collaboration between hardware and software is essential for the device to function properly. So here, the employment sectors will be IoT and smart device companies, electronics and semiconductor companies, automotive electronics, defense electronics, all these are the major employment sectors. And you will be called as electronic system designer or a digital system analyst or a IoT developer. So these are some courses. And here, the need for mathematics is not much, because with the average level of mathematics, I will be able to work with computer science, not a problem. With minimal programming, I will be able to work in this area. But the major thing is the domain knowledge. Now, whether it is communication engineering or system engineering or this electrical or electronics engineering, I should have around 70 to 80% of these areas work under the domain knowledge. And this computer science is an additional knowledge that is required to interface these devices to automate the things and make our work easier.
So it is right to say that because these programs have a dominance of core subjects,
Yes.
so the students should be at least comfortable with handling those subjects.
Yes.
They should not misinterpret it thinking that this is a computer science only.
Yes,
So I have
that
to
is
do
a
only
very valid
programming.
point.
Yes.
Very valid point. Because no, when they think that, oh, it is computer science and electrical engineering. When it comes to computer science and electrical engineering, there is another word for the course in some other university. They call it as computer engineering also. When students see that it is computer engineering, they mistake it for computer science engineering and they get into that course. But actually what they do is they learn a lot of electrical engineering over there when it comes to computer engineering. When it comes to computer science engineering only, it is dealing with database or programming language, all those things. So without understanding what the curriculum is all about, we are not supposed to choose the course, because when it comes to this electrical, electronics and communication engineering and all, a lot of physics comes into existence there. You will have to know a lot of physics, and you need to have that understanding in physics and the interest to learn that. So that is going to be very important. If I don't have interest, I will not be able to work in that area alone, right? Because the computer science part is not very big, but yes, of course, computer science gives life to that particular work, but the domain knowledge is more over there.
So a major takeaway from this webinar should be for the students that please look into the program curriculum. If possible, look into what are the syllabus of that course, just to see how aligned you are. Moving forward, now we see maximum students today, they plan to get into a pure computer science program, the domain of computer science. Even the educational institutes are now coming up with a range of different courses under the major umbrella of computer science. And with so many specialized computer science programs available at undergraduation level right nowadays, I'm sure our audience would also like to understand that how a 12th grade student should go about selecting these programs. Ma'am, if possible, please take up one question from this chat box. They want to also understand something related to cybersecurity, which I think the next question would also maybe able to answer.
Yeah. See, when it comes to cyber security, it is a very good area. Yes, it is an emerging course also because and as the technology is growing, as the transactions and everything is happening in the happening online, cyber security is going to have a good boom, and every organization or company will need a cybersecurity professional or an information security analyst or ethical hacker. Definitely, you can get into it. That's not at all a problem. But at the end of this, I will help you understand many other things also. Anuradha, I will help you understand. Let me finish this slide because all this slide is about the areas
Right.
related to computer science plus what is the technology that you're looking for. Now, coming to this, we have listed something like computer with AI, ML, IoT, cloud computing, data science, cyber physical systems, and lot more courses are available. Because within this 1 hour, we will not be able to cover all those courses. So we have handpicked some of the courses. And you will have to use the same strategy when you are looking into other courses also. So when it comes to AI, we all know it is something that mimics human intelligence. And when it comes to machine learning, it is about where computers learn from data without being explicitly programmed, right? For example, I can tell one thing. It's like training a dog. The more it sees or experiences, the better it gets performing a task. It is like that. In case of ML, a computer uses data to improve its performance over time, just like a dog learns new tricks by repetition. That is the exact thing. So when it comes to this AI, all of you must have seen voice assistants, Siri, Google Assistants, Alexa, and all. When you ask Siri a question, what is the weather today? And the Siri doesn't just search it on the internet for an answer. It also uses AI and ML to understand your voice and process the information and respond to it intelligently. Okay, so these assistants learn to recognize words and phrase by analyzing the past conversations and data. Over the time, they improve their accuracy and understanding of your specific voice or speech patterns also. Even in the email also filters, the spam detection is nothing but AI and ML. It automatically, first it will understand, the system analyzes the characteristics of incoming emails such as the sender, the subject line and the content, comparing them with the known spam emails. Over the time, it learns to detect the spam more accurately and it processes the data. So that is computer science with AI ML. So the major employment sectors are tech giants like Google, Microsoft, Amazon, and a lot of AI startups in automation, natural language processing, industries like healthcare, finance and all, they look for fraud detection, and healthcare, they look for diagnostic purpose. For diagnostic purpose, it is an excellent thing where it will not miss even a single thing. With a large amount of database, it easily finds out what is a problem in a person and help the doctor to identify it. So that is about AI and ML. And when it comes to computer science and IoT, IoT is a concept where everyday objects are connected to internet and share the data with each other. The best example, what we can say, is the wearable device, right? The fitness trackers and all. So it is a perfect example, the wearable device. How it works is when you are when you're wearing it in the hand, it helps you to understand the heart rate, track your steps, and even notify your irregularities in your health, right? So these devices collect this data and your physical activity and send it to your phone or the cloud service. So from there, you can download the information anytime from any part of the world. That is how this wearable health device works. And again, the employment sectors are smart device companies like Honeywell, Siemens, Bosch, and industries like automotive, cars, that is self-driving cars, or healthcare industries where they use wearable devices. They make a large amount of use through wearable device. So the roles you will be having will be IoT developer or embedded systems engineer or IoT solution architect also. And when it comes to cloud computing is about using a computer or a service over internet without using the physical hardware. So whatever you are working on a computer will be stored in the internet cloud. And this storage will help you to reduce your cost that you are spending for a physical server, and it also help you to save your data, large amount of data, cost effectively, and it also help you to access the data anywhere from any place. The best example is Google Drive. You all of us are using Google Drive, right? So it is when you are uploading files or photos or documents and store them online, these files are stored in a large data centers on your personal computer, and you can access them from any location. It can be through phone, or it can be through tablet or laptop also. So this is how this is nothing but the technology that works behind this is cloud computing. And when it comes to this cloud computing, the major part is that information systems. Students who wants to choose the cloud computing, they have to be very sure that at least they need to have that interest to work with the information systems. Information systems means they are some of the systems that collect, process, and store the information to support decision making or coordination or control, whatever it is. The system can be, for example, hardware devices like physical devices like servers, computers, routers, and network equipments. Some of the software applications, data like raw facts and figures, people, users, IT professionals, procedures and rules that govern the use of management of system. All these are nothing but the components of information systems. So as a student, I am not somebody who like to work only with computer science. I should also work with these information systems. For this, the students can also study IT or information technology or information science also. It is not necessary that they need to go only for computer science also, because it deals with information systems. If the student has interest there, they can definitely, when they take up this particular course, computer science plus cloud, they can make a good career in that because their interest makes them to do. And when it comes to IoT also, computer science and IoT also, what happens is the major point where they will be working will be with the electronic devices. So they need to know that where they are working, the environment will be electronic devices, and they will be adding software to that. So the students should know that when I am taking that IoT, more I will be dealing with electronic devices only. So my interest to work with the electronic devices plays an important role to keep me attached to that particular job. So that is very important when I am taking that kind of courses. So when it comes to cloud, computer science and cloud, the employment sectors will be Amazon Web Services, or what else I can say, Microsoft Azure, Google Cloud. These are the major cloud providers actually. So you will get the job opportunities will be given by these people, and IT services like Accenture, Wipro, TCS, Infosys, all these people, they will give opportunities. You will be called as cloud architect, or a DevOps engineer, or a cloud security analyst, or a system administrator. Like that, you will be, your roles will be like that. And when it comes to computer science and data science, we all know that by now I need not explain what data science is, but still it is a process of using data to solve problems, make decisions, or find patterns. It involves gathering, cleaning, analyzing, and interpreting large amounts of data to extract some useful information from that data so that it is helping you to enhance your business decisions, right? For example, imagine you have a huge pile of puzzle pieces. Okay. Data science helps you to figure out how to put those pieces together to see a big picture. So whether it is predicting what a product you might buy, how likely it is going to rain tomorrow, or how much the company stock is going to have, everything is nothing but data science, right? So for example, another example I can give you. We all have a habit of seeing pictures, any kind of shows in Netflix, and we use Amazon like platform for buying things, right? Every time when you are going and accessing the Netflix, it suggests shows, or Amazon recommends your products you might like. That is where the data science work. The system looks at your past behavior, what shows you watch, what you bought, what videos you liked, and analyze the data and recommend you the things accordingly when you are accessing that every time. So it is nothing but the patterns. It is by looking the pattern in the data, you are able to compare this and with the other users' data, and the system predicts what you might like. So this is how it works. Big tech company like Meta, Netflix, Amazon are the major recruiters for this data science. Banking and finance, any industry in banking and finance, JP Morgan, Goldman Sachs, or PayPal, they are also very good recruiters. And even healthcare companies like biotech firms and hospitals are also good recruiters in this. And last, I will get into the cyber physical systems. Most of the students, many students mistake it for cyber security again. So this is not cyber security, it is cyber physical systems. It is like now sometimes I am using automotive vehicle, means self-driving car. Let us think. A smart car uses cameras, sensors, and GPS to understand its surroundings, like road conditions, traffic, and pedestrians. So the onboard computer processes this data to control the car, steering, accelerator, and brake without human intervention. So the cyber part is the algorithm and the software analyzing the data. And the physical part is the car, the sensors, and the wheel moving. So this is cyber physical systems, right? So these systems use sensors to gather data from the environment and analyze the data with software and then make decisions and actions automatically. So they are bridging gap between physical and the digital world. So that is how this works, cyber physical systems. And here here also the major what is it, recruiters will be this Tesla, and all these automotive industries will be the major recruiters. Now here, what do you understand? What is the takeaway from this slide is, when it comes to artificial intelligence and machine learning, and even if I am getting into data science, whether it is data science or artificial intelligence or machine learning, I need to have I should be very good in mathematics, and I should be familiar with my programming ability. If that is the case, it is easy to take up this particular course. There's no doubt in it, because strong basics in computers is important, a little bit familiarity, just ground level knowledge about programming, and good knowledge in mathematics. That is very much important to learn that particular subject. Now, coming to IoT, as I was telling, an interest to work among the electronic devices. Cloud computing, again, an interest to work with information systems. Like that, each course has certain demand from the candidate who is taking up that course, because learning the course is possible anytime. 4-year graduation, I can somehow do it. But later, I will be working in the career where this environment is going to be available. I should know whether I align with that environment or not also, right? So it is important for us to understand what are the prerequisites to get into such courses.
Right. So, ma'am, there was a question here. I think you have answered it to an extent. Is mathematics important for all these programs?
Yes.
Yes.
Maths is important. You need to. So as I told you, AI, ML, data science, maths is definitely important. It is going to be the major part when it comes to AI, ML, and all. Data science, maths is going to be important. Other areas, not a large amount of mathematics, at least medium level of mathematics is more than enough. And when it comes to computer science and engineering, you can manage with average level of mathematics also. That's not at all a problem. Okay? Yeah.
So one more thing that most of the students keep wondering, that is it important to have a BTech degree for these advanced courses, or we can also look into, a BSc in computer science or something like a BCA program?
Yeah, definitely they can look into BSc program also. It is not, there is no mandate that I need to have only what you say, BTech program. You can definitely have what you say, BCA, or what you say,
BSc.
yeah, BSc program. That's not at all a problem. They can, but what the thing is, what you have to do is you should see when you are taking BSc means I am somebody who will have more, I will be learning more general and science oriented undergraduation because it will have more of scientific concepts also. Computer science topics includes theoretical and practical aspects. They cover a range of topics, including computer programming, data structures, algorithms, computer organization, computer networks, and software. All these things are available in BSc. That's not at all a problem. But what you have to look into is here, when the student is completing BSc, they have to take up some master level courses. When it comes to master level courses, it can be related to their interesting areas. Suppose I want to get into AI or machine learning. After doing BSc, I can definitely take up a master level course in AI or ML, or I can take up a master level course in data science also. That's not at all a problem. And even BCA students also, they can also take. But the thing is, what the BCA students should think is, when it comes to AI, ML, or data science, maths plays a very important role and they will have to do a lot with mathematics. Otherwise, also, BCA program will have at least one semester mathematics. And this mathematics depends upon the intensity of the mathematics depends upon institute to institute.
Right. And a lot of reputed colleges and universities, they have recognized and good programs related to BSc computer science also.
Yes, even course with mathematics students also, they are accepting if they have mathematics.
Yes. So student with who do not have a science background, they can also opt for BSc courses with mathematics as a major eligibility in most of the colleges. Student can also look into some modern age colleges like, Scalar and all, who have a very industry driven program for them. So this brings me to the another question, that when students are preparing for these kind of programs, what is the kind of preparation that they should be doing? Something apart from their subject knowledge that they should also look into, some coding, programming related things that they should also look into.
So
Before
are you
getting
asking
into this
about the
programs.
upcoming generation students or the 12th grade students?
Upcoming generation students, what they should, look
See,
into
now,
these kind of skills.
for now, I see some of the parents are also have joined. So when it comes to this computer education, year after year, the bar for the education is increasing. So I wish students should start learning computer science at their early age, maybe from 8th grade onwards. They have to enroll with basic courses. The learning shouldn't be a burden for them. Don't build expectations, no comparisons when they are learning this. Allow them the space to learn it, considering it as an extra skill like they do singing, dancing, and playing, so that they learn to manage to work around a couple of programming language by the time they come to 12th standard. Because by the time they reach 12th standard, when they have good knowledge about computer science and how to deal with it, it will be easy for them to continue with this advanced technologies like AI, machine learning, quantum computing. All these emerging technologies are going to come, which require strong basics in computer science and familiarity to the programming languages, including the efficiency in mathematics. So the students will have to learn it without any burden. And as I told you, no expectations, no comparisons.
Ma'am, going towards one question from chat box. Computer science engineering, we are talking in detail. We spoke about the relevance of mathematics. Is physics and chemistry also important part of it?
See, when it comes to computer science, chemistry is not playing a larger role there in computer science, but physics plays a role in computer science, because when you are learning about the internal parts of the computers like data storage devices, motherboard, ROM, RAM, and all, you will be accessing that multiplexer, shift register, all these things. You will be taking it from the lab of physics. So definitely physics is going to be a part of this. Chemistry is not playing a larger, what you say, part in this, that I can say. And when it comes to AI/ML, those who are studying AI/ML and deep learning, natural language processing, and want to deep dive into those areas, physics should be there along with mathematics.
Ma'am, very quickly, we should also talk about some interdisciplinary kind of engineering programs. There are a lot of questions related to this. There is a question related to a biomedical science engineering also, if you can take up in this slide.
Yeah, when it comes to this smart manufacturing, it is about, see, when it comes to smart manufacturing, machines that are equipped with sensors and softwares, allowing them to monitor themselves, adjust automatically to themselves, we call it a smart manufacturing. And this is one thing that is going to come up very well, where manufacturing, and the students will learn about manufacturing engineering, smart technologies, data analytics, integration of IT and OT, and sustainability informations, innovations, etc. And when it comes to nanotechnology, it is about dealing with instruments or machineries that is in the nanometer, in the size of nanometer. So when it comes to nanometer, they are something that is engineered in the atomic and molecular level. So for example, when you are using this very easily to understand, I will use one thing. Imagine a sunscreen lotion that you are using. When you are using the sunscreen lotion, you have zinc oxide in that lotion that blocks the UV rays more effectively, right? So this zinc oxide in the visible, if when it is visible to your eyes, the size of the zinc oxide, when it is visible to your eyes, it doesn't own that property to block the UV rays. But when it is on the nano size, means of the size of 10 per minus 9 meter, it acquires that property to block the UV rays. That is why we are at the back of this nanotechnology, and this shows that how this particular technology is going to be important, right? And when it comes to biomedical engineering, it is about dealing with biological devices and equipments that is used for diagnostic as well as therapeutic purpose by the doctors in the hospitals. You imagine if you could design a machine or devices that help doctors to diagnose illness, treat patients, or even replace the damaged body parts. That is what the biomedical engineers are doing, designing medical devices like pacemakers, artificial limbs, or improving the medical equipments like MRI machines, X-rays. This is what the biomedical engineers do, and this is one of the emerging career, and this is one also a very good backup for those students who are writing NEET. Even PCB students can also take up biomedical engineering if they are very comfortable in learning mathematics. This is an underlining statement. Very few institutes throughout India, they are offering this biomedical engineering for PCB students also. But the condition is they need to learn mathematics, because in the curriculum, mathematics will be there. Without mathematics, there is no engineering. If that is the case, we can definitely do that. And when it comes to material science, it is about understanding and improving materials around us. It's like being a material detective who tries to understand how different materials behave and how they can be used to solve different problems. Imagine you are making a new phone or a new car. You need to pick a material that is strong enough. At the same time, it should be lightweight, and at the same time, it should be safe. This is what the work of a material scientist. So they find a lot of that is demand in manufacturing industries and automotive industries, aerospace, energy and environment. And this particular domain is growing like anything. There is no doubt at all, because we are trying to access Mars. We are going to different planets. The rocket has to carry everything lightweighted. So for that, we are trying to work on composite materials, lightweight materials. All this comes from material science and engineering again.
Thank you.
Picking up one question from the chat box, you said that for students with biology, they can go into biomedical engineering. Can students without biology, with mathematics, can also look for biomedical engineering?
Yeah, absolutely. Absolutely. Biomedical engineering, PCM students are very much invited to do biomedical engineering. Within the curriculum, they will expose you to relevant topics of biology. That's it. Definitely.
Ma'am, one last very, very specific question, because we are almost towards the end of this webinar. Most of the science students, they are now gearing up for JEE exam, and that is the national level entrance. What would you suggest? What are the other things that they can also look into just to have some backup plans, or after they see their performance in JEE, they would also start wondering what else to do? So quickly, if you can answer that for the
Definitely,
audience.
JEE is one of the difficult exam. I understand that. I suggest all of you should write this national level entrance exam JEE mains, because when it with the JEE mains, you can get admitted in triple ITs, you can get admitted in NITs, and also lots of private colleges are
They also
accepting
take.
this JEE mains. Every college will have prescribed number of seats through JEE mains, through their institute level entrance exams, through state level entrance exams also. So you can definitely apply for engineering students have enough opportunities. One is through JEE mains, another one they can get into bifurcate some institutes, and they can write institute level entrance exam. They can also expose them to state level entrance exam also. They can write, every state will conduct state level entrance exam for professional courses. So definitely they should have a backup. Those who are writing JEE definitely should have a backup, at least 2 or 3 institutes and the state level entrance exams also.
Ma'am, and apart from state level, also institute level entrance, that, like you said, private university entrances. There are also some modern age universities who look into application, aptitude exams. The like universities like Plaksha and Scalar, they will also take up application based admissions also. So they should also explore these options as backup. Uh,
Okay,
Great.
sorry
Yeah.
to interrupt. There was one last question where from Miss Neha Gandhi. She's waiting quite patiently, and she's typed in her question several times.
Okay.
She's mentioned that please suggest a good college in Mumbai that offers computer science and financial technology. If you could just
See,
shed
when
some
it
light
comes
on
to
that.
financial technology, it is not available in Mumbai right now because it is one of the rarest course. And it is available with Manipal University here in Bangalore. It is one of the thing. And those who want to get into financial technology, they can definitely look for mathematics and basic computing. In that is also not available in Mumbai colleges right now, but in most of the other states it is available. And if you can connect with us, we will definitely help you with that college list also. No worries.
Sure. Thank you so much for answering that. Of course, to all the people there who are attending, we have typed in our information in the chat box. Like Dr. Sunita said, that please reach out to us for any support that you require, any queries or any help. We have limited time on these webinars, so we can't take up all the questions. And if we haven't been able to do that, we really apologize for that. But please feel free to reach out to us. All our contact details are already mentioned in the chat box. I'll type it once again for easy reference. Please reach out to us and we'll be happy to help you. Dr. Sunita, Ms. Anandita, thank you so much for providing such insights. It was really, I'm sure it has been a very helpful session for all the students and parents and educators who have joined this webinar today. Stay tuned for more webinars. We'll be bringing you more such webinars on different career opportunities and different streams to help you better. Thank you so much for joining in. Thank you.
Thank you, everybody.
Thank you
Thanks
so
a
much.
lot.
Please feel
Thank
free to reach out to us. Thank you. Have a great weekend and a great evening as well. Thank you.
Thank you. Good night.
Good night. Thank you.